So I am going to start off by turning this into an actual workable picture. I'm going to use the pen tool in Photoshop. Click, click between the 2 points, and then I want these anchor points to turn this line into a curve. Looks like there should be a thing up here, and then it looks like there should be another one at the apex up there where it sits on the shoulder. See, we're just going to move it here. We drag the arms. So once I have that, I'm going to fill that layer with white so I can see what I'm doing. And then we go, whoop, and then we go right click, stroke path, poof. The next step is, so we know this is 30 inches, but we're going to make it an actual 30 inches. Image size, boom, and now we have a life size. If I print that out now in multiple sheets, that's a life-size copy of the shape I'm trying to duplicate. So now the next step is I have the curve printed out that it needs to be at, and I have this bounding box of total desired dimension, and so I'm going to pencil draw the khopesh, and then get that back into the computer and then trace over. You know, like I could draw the whole thing on the computer, but I find that the pencil line is more spontaneous than the computer lines. So then after I have the drawing more or less where I like it, I put it into Photoshop. So then I position the drawing inside this Photoshop frame I've got, such that the center line's running up the middle, and I aligned that curve such that it was where I wanted it to be. I moved this handle a little bit down so it was more lined up with the center line, although the concept of center line is a little bit funny on this shape of sword. Then I used the line tool to carefully do a nice printable outline. You know, I can print these guys out and use them to trace and cut parts and print out multiple copies again and again if I need multiple copies so that everything will line up. So then after doing the Photoshopery, I print out my life-size copy. I'll probably have to, I usually have to print out a couple of these, but I normally only need one printout for the blade. But I like having the life-size copy. You get a real good sense of it, This is weird. I mean, everything I make is weird, but this one is particularly weird. I think the tip on this guy is getting a little knackered, but I mean, I do use it a lot. Bloop! Ah! I dropped it! A 3. This is ½ inch, so I definitely might put in a new tip. Whoa! Come on! There we go. So these 3 guys coming together. That's kind of like the basic idea for the pommel. Whoa! So that's all the parts I need burned out except for the handle. I want to get a massive piece of round bar and just carve that straight out of the piece of round bar. So just for giggles, I put all the raw parts in a bag, hung them off the spring scale up there. £29 plus a missing handle, which might add as much as 5 extra pounds, but that's still £34, which is not terrible compared to one of my things. I was slightly worried about this one with the weird shape, but it should be manageable in that the person should be able to lift it up at least. I don't normally weigh these things beforehand, the weight's going to be whatever the weight's going to be. So normally I don't like setting up the vinegar bath inside, but it's really cold out. The reasons I don't like setting it up inside is one, the stink of vinegar, the whole place smells like vinegar after you do it, and 2, just cleanup is messier. Anything I spill while emptying the bath winds up on the floor of the shop instead of just on the ground outside. Someone in the last video asked yet again what the purpose of the vinegar is. It dissolves the scale on the surface. The reason you want to dissolve the scale on the surface with vinegar is just to save on abrasives. The scale there is extremely hard, and it's just regular white vinegar. And this was old stuff I used, because the one bottle of new stuff is all you should need. So this is just filler. Here they are the next day. You can see all the bubbles. The bubbles means it worked. You can see the slight colour difference between the paradox and the mild steel. It's subtle, but it's there. So what I'm doing here is I'm cutting pieces out so I can actually mark these guys without having a bajillion little individual little pieces of fingers. You know, so that how do I cut pieces out so I can mark them, but also mark them so that they maintain the relationship to each other, you know, because even if I did cut loads of individual sections out, it would get very messy. So I'm adjusting this outline so that when I flip it and go to trace on the other side, it will be actually, you know, tight to the edges. You know, there was a bit of furriness around the edge just for the plasma cutting. So I'm going to carve this detail into the surface, Grimshaw style. I need this to not be too bulky, and if I get into welding and grinding and stuff, having a big, huge weight here at the top. So I'm just going to see what it looks like just to do it by Scrimshaw with the old pencil grinder. So forth and so on. That's the idea. It was a long job. Be a pretty good fit with these parts. It'll just make my life easier. I hate that stuff. It's the shrapnel that comes off the die grinder. If your bare hand went down on that, you'd have a bad time. So, I wasn't even going to film this experiment because I didn't think it was going to work. But it's not only has it worked, it's worked explosively well. It's still fizzing away. I mean, yes, that looks gross. But so what we have in here is we have a metal plate on the negative. We're set to 6 amps 12 volts on the charger, and on here we have a random sample piece I cut, a sample cut, but this has been in here a total of 10 minutes, 20 minutes maybe. Like I said, I wasn't keeping super good track of this experiment because I didn't think it was going to work. Normally when I try this kind of etching stuff I use vinegar, but for the laugh I'm using salt water now because I heard it, you know, I read an Instructable where the guy had pictures up and it looked like it worked better. So, oh, hello cat. But it's worked explosively well. Now I did use a lot of salt because I just wanted to be sure that it would work. But cost effective wise, it's salt. It's just water and salt, you know. Salt is cheap. So I'm going to maybe take it out now and clean it up. It's burning so well. I'm actually worried about undercut, you know. Not so much about whether it etched, but whether it's etched too much and it's starting to go under. That's just tape, like just regular parcel tape. I cut a design into freehand. So let's see what it looks like cleaned up. Normally, when I do an etch, I'd worry about, my main concern would be that it would be way too shallow, and that like while it would be okay for handles and small little things, it would be sensitive to being damaged. But this is astonishingly deep. I mean, we're still not talking, you know, we're still talking less than a millimeter, but a good fraction of a millimeter. It's definitely, it would be a body of work to grind this out, you know. You certainly don't have to worry about doing it by accident. It did undercut, that's the other thing. It was so aggressive etching that it undercut here. Now, it was only shitty packing tape I used because this was just the experiment. I wonder, like, if you had a full vinyl cut, would that adhere to the surface better and be better able to survive the aggressiveness of this? But I'm very pleased with how this turned out. For I'm only going to pour a tiny amount of effort into this because I don't believe it'll work type experiment. Whoop. The middle part of my goggles broke. The part of the bridge. It only happens every so often. You're supposed to use like bathroom chain, you know, like that the stuff that holds your sink, your stopper in place. But I use cable ties because I have so many of them lying around, and they're easy to, you know, they have finer adjustments. This gap is extremely important because even if it's only a little bit off, that can start to drive you crazy if you multiply it by the hours you have to work. So for doing the handle piece, I couldn't find a huge big bar that was the same, that was the correct thickness, that was long enough. But I did find these were one piece before I chopped it. So I have these two pieces, and I'm going to weld this part in the middle, which seems kind of silly and a lot of work, but I actually like this kind of fiddly stuff. I thought this was 2-inch, but it's not. It's actually just the tiniest fraction less. And so then whenever anything with inches gets into tiny fractions, I revert back to millimeters. So this space in here had to be the gap to make it so that this is lined up with the middle of these had to be 5.5 millimeters. So then that involved a lot of dicking around with these little slivers to see how many of them brought it up to 5.5. You know, and it's all set in this angle here, so like, you know, you have the same amount of these shims here and here, and then blump blump blump. In theory, everything lines up. You know, I don't know, can you see it, but I drew around, before I took this bevel off these guys, I drew around it, just to make sure, to be sure. And if there is a difference, it's a difference that's too small to detect on the thickness of one of those thin Sharpie markers I use. Now I'm just going to let that cool down a bit before I try to unclamp it. Luckily, this knobby bit, the part I cut off here, still had a thing left from some obvious you know, time it spent in the lathe, so it's got a centered hole already to guide me. Operation Reckless Endangerment Phase 2 is ready to begin. So now to do this very last bit, I had to swap things up a bit, you know, because this is what you're dealing with when you don't have a real lathe. So I have this wooden thing here, which I'm not happy about, but at least it won't mar. If I had another, you just use the same steel piece, it would almost definitely mar the surface, which I've already gotten down to where I wanted to do. So now just to get this guy, this last piece, so set it up, you know, at a different height, and I had to put this. Oh, can you see? I don't know. There's this other piece of steel clamped underneath the rig and touching off here, you know, coming out and just touching off it, because the chuck, when I tried this the first time, it spun and then it just dropped out. The poor old chuck, which is designed for what does it say, 15mm drill bits, and I'm hanging this you know, 5-pound giant weight that's heavy at the end out of it. It just wasn't, the poor old jaws in there weren't able to grip it while it was spinning. Oh, it's way wobblier with the. It's way wobblier with the wood than it was with the steel one. But yeah, that's it done finally. So there's the handle and the template. Because I wasn't able to find something 2 1/4, this is only 2 or slightly less than 2. It's slightly different than the template, but since this isn't a replica, since this is one I designed, I'm willing to live with that. If I take this away and don't look at it, I think that looks fine. You know, it's acceptable looking. Yo, it's still hot. Big lumps of steel, they hold the heat for ages. Years from now, someone looking at it will go, how the hell did he make that? Actually, probably not though. Because we live at the very edge of 3D printing being a thing, we're about to stop being curious about how weird shapes got made. Someone who recognizes the marks might wonder what kind of lathe did that, and I guess I'll have this video for a horrifying answer. That line there is from the wood. I'll have to buff that out.
What? What the hell?
What?
Is that as loud as that gets?
No, this one has an adjustable speed.
What?
Yeah.
Where'd you get that one?
The Bosch sent it to me.
What?
Yeah.
Oh, because one of them broke? Or something?
No, they did the Bosch sent me a box of presents a month or 2 ago. Not a month or 2 ago. Last year.
Really?
Yeah.
A bunch of grinders. Oh.
Yeah.
Oh, nice.
Yeah. If you would like your tools featured in a Michael Cthulhu video, send me a big box of stuff. So I was just taking the furriness off the edge with the big angle grinder, but I find this guy tends to, because of the size of the wheel on the angle grinder, there can be like these little ups and downs, but when you use the sander afterwards, because it's, you know, bigger and flatter, it tends to even those out. You get like a relatively smooth curve. Front side is going to be sharp because it's supposed to look bony as opposed to, you know, it's supposed to look more organic. So I'm probably going to roll the edge, you know, not have it be that sharp line that I normally do. Like, I'm going to grind it as if I'm doing that to begin with, but then at the end I'll roll it. It's been a long time since I mentioned it, but the reason I grind them at this height as opposed to at the regular bench height is to save my back. know, holding the grinder for hours at this height puts way less of a strain than if I was grinding down. Especially when I have to check is the actual edge in the middle of the blank. So this sharp transition, this is what I was talking about, this sharp line. Probably going to roll that out to make it look like a, you know, more of an organic shape than my usual blades. Pains me to do it slightly, but it's the right look for this one. The nice sharp line is more skillful kind of thing. Oh man, that's both sides sharpened now, but I have to take a break. I can't feel this one anymore. Combination of the temperature and the grip. What have we here? A couple of videos now people have been telling me to get a TIG welder, as if this was a thing I was mysteriously unaware would make my life much easier. Hang on, I don't want to break stuff. That's the spare bits. Gas line. Oh, this is one of those guys that in theory you can run on either power. I hope that's the type of plug I already have wired up for the plasma cutter. Foot pedal. Oh, it comes with the sleeve. That's good. Some of them don't. You have to buy that extra. Tip. The torch regulator. Oh, it is mostly just a giant box. Electrode, holder and lead assembly, work clamp and lead assembly, and the actual welder itself. Oh, cool. Now I don't know shit about TIG welders, so I bought it off the guy I bought my MIG welder off a million years ago. I had to get argon, pure argon. The regular welder uses a mix. For the TIG you need the pure, apparently. I'd forgotten that before I bought it. Let's fire her up. Cool. Press this guy to do different. Oh, it's set to DC. The AC is for aluminium and stuff, but the DC is for steel and stainless. That stuff controls the pulse. Not going to bother with that, I don't think. Amps. Let's give it 100. Haven't TIG welded anything in maybe 10 years, maybe, since I cannot remember. So that was fighting me, like even maybe 100 was a little too low to have it set for the 1/8. I mean, the TIG welder's speciality is doing the thin stuff without making a horrible mess. Yeah, you could. I haven't looked at the footage yet, but there was the main thing to note is the lack of sparks flying everywhere. There's no spatter, so you can you know, you can do little delicate patches and things on onto things without worrying about making a mess of everything. Yeah, so as you can see, I was kind of rusty, but I still remember how to do a bead. It's just, you know, those are kind of high, like the 100, like I was saying, was too low. So anyway, there's the TIG welder that Patreon bought. Thank you, everyone. So Rexcut were good enough to send me some fusion discs, they call them, interleaf flap discs. They're Scotch Brite and sandpaper combined. I find they're really good for doing weird shapes. You know, if you're trying to smooth out a weird shape and make it look, take away all the grinder marks. You know, weird shapes is practically, you know, a two-word description of what my business consists of. These three claws, they don't line up with anything. They, you know, they point at each other. But it makes my life a little bit easier if they're somewhat similar before I begin. Time to grind. That's just an old strip cut out of an old belt. It's an old trick. I used to use these on joints when I was doing railings and stuff all the time. These bevels, or when I'm joining, I won't be able to get them to stand one-handed. But the three of them, three of them stand facing each other. I photoshopped this shape together. This should be good enough to position the claws such that they're in the middle. That they make it that the actual angle between each one is more or less the same. It is cold here. Oh, that was crazy. The big halogen light was fooling my helmet and I was trying to shield it and wound up shielding myself and had to do well, I've never done a TIG weld blind before. This TIG it's handy for doing the tacks, for positioning things without mess. So I'm liking the TIG a lot. I used it to do these back welds, which ordinarily, you know, would have been okay, I guess, with the MIG, but they're just a little bit more delicate. And that one in the middle, I got with the TIG as well. These huge big ones here with the big gaps, I'll switch over to the MIG for that. But yeah, TIG, it's nice. Also, I'm not even sure how it's welding this, because that thing is only rated to 1/4 inch. My initial thought that was that it was going to be okay for tacking things, but the way the flow was going, I can't imagine it would be that disastrous to use it for full welds and stuff. I mean, this is all that's really thick, and those claws are made from 1/2 inch. So who knows? You can see all the colours from the heat. That's the heavy build with the MIG. Woo! These gloves, I got these gloves for doing the TIG welding. They're a little bit thin for the MIG welding. But yeah, you can see the build in between each joint. So when I grind that back, it will be, you know, indestructible. You'll bend these talons before you'll actually knock it off the end of the... I'll come back and modify it in a bit, but that's the basic idea. Now I'll do the next side. I don't know, was it because it was so narrow, but this guy was fighting me the entire time. So now that is a vinyl printout of the shapes that I want to transfer to these guys. I have a second one over there. A buddy of mine was good enough to do these for me. I do not have a vinyl printer. And so what I'm going to do is pick out the shapes I actually want to get burnt into the steel and then carefully transfer this to here. It's somewhat hair raising. You only get one shot. This is the part I'm dreading the most, where I actually have to transfer the design. Hang on, I'll do this first. I wish I had more hands. So in theory, this stuff is less sticky than that opposite side of the vinyl, but it's sticky enough to lift the vinyl off its backing. Then once you use this to lift the vinyl off its backing, you do a quick swap. Now I'm going to go around the edge. Luckily none of it's buckled on the edge. I can see some of these parts where the curve goes both ways got buckled, but whew. I don't know, could you, that was stressful. I don't know, can you tell how stressful from the clip, you know. But if I had done that wrong and messed up the vinyl, I'd have no option than to phone my buddy up and try to get one printed out again, yada yada yada, just go on and on and on. This is what I'll burn the stuff in. It's just salt and water. There's no exact recommendation for how much salt to use, but the more the better. And you know, salt is cheap. So I've just taped up the back of these guys and added a wire to the back. Stripped the end, you know, scrunched it up so that make sure it's making contact with the back of this. The reason I want to do these at the same time is in case something weird happens, I want to make sure that they both etch to the same depth. There's no super guarantee that they'll even etch to the same depth doing them at the same time, but has to be better than doing them separately, you know. Okay, so here goes nothing. That's a car battery charger set to 6 amps, 6 volts. The negative is connected to a piece of sacrificial steel in here. The positive is connected to the backs of the blades. And we're about to power it up now. You can see instantly a whole bunch of bubbles from the sacrificial piece of steel. And hopefully it'll start to etch. The time is 12:26 a.m. We're going to leave it do its thing for 10 minutes, check on it. Gross. Now it's been a total of 20 minutes in the bath. Wait, unplug it first. I'm tempted to leave it longer. Another 5 minutes. So, the burn was a success. All of the pieces are thick enough for me to not thick enough, deep enough for me to catch a fingernail on. All the pieces, all the burns. Like a blind guy could tell what these were. So I mean, I still have to be a little bit careful, but not super paranoid about buffing these off. It would be a lot of work to remove one of these from the surface, which is what I wanted. I wonder, is that just rust? There's an odd copper-like deposition inside of the burn. Like, I wonder, does it have something to do with the copper wires used used for the, you know, like to connect everything up? Although, you know, nothing should be deposited in here. This is a zone for stuff getting burned away, you know? So, don't know, it might just be rust that looks coppery. You can see now, it's more obvious now that the edge is blended into the surface, you know. There's no clear, sharp distinction between where it starts to come down and where it is flat. Someone asked, could they go blind looking at their welding on the screen? No, is the answer. Might be uncomfortable to look at, but your computer monitor cannot produce rays equivalent to the welding, so you don't need to worry about that. So the welds from the TIG welder are much smoother, zero spatter. Hopefully that'll result in less cleanup time. There was a gap there I was welding into. Since these are surface details, I'll still use the MIG for doing the handle. I'll probably do the very start of it with the TIG weld. That little first bit is always hard to get with the MIG welder anyway, and then do the heavy build. That's where the plug weld was. I'd only say was because you can't see it anymore. But it was a hole, same here, a hole welded into the hole. I just wanted these corners, you know, it's joined here along the edge, but I wanted something here just to really stick this onto the surface. So oftentimes when you do a weld, there'll be like weird little undercuts and stuff, you know, like little bits that you have to fill in afterwards because you're like, oh, it melted too much there. See, like these are the two side plates welded together down the middle. What the TIG welder is good at as well is getting those little bits. You know, you don't have to like set up all the rig where everything is protected from everything again. And the little zaps are not, I mean, they're not little zaps, they take more time than with the equivalent with the MIG welder, but it's just easier to control and fill in all the little extra bits, and you don't have to worry about spatter. So yet another thing the TIG welder is great for. Got to do that on the other side now. This was sent by a well-wisher. Thank you again. 3/4. So I need to levitate the blade portion by 7/8 and the handle guard portion by 5/8. So that's the correct height. Now I just want to do some prep. I'm going to grind this in so I actually have more space to zap in there.